Hey, Top Analyze Math Industry, and we are going to take a look at the distance, the velocity, and acceleration on a graph. So the main question for today is, if something is in some kind of motion, what happens to its distance, its velocity, and its acceleration? We've definitely learned about these kind of graphs over there in another video. The one about if you go up and you go down, and the other one about if you're at rest. So let's understand what these graphs will look like. And what we're going to do is use my school assignment piece of paper because the chart is all over here. And the other thing is I don't want to kill more trees and waste more paper. So here's what we're going to do. So here is the first graph. You are taking a look at your distance. And your distance is being compared by your time. Your distance is your y-axis, and your t, representing time, is your x-axis. So if something is at rest, the line is going to be straight, because if something's not moving, time is the only thing that's moving. So anything is at rest will stay at rest. But also time is going to move. If you talk about the velocity, velocity is not going to be happening either. Nothing can't move. And number two, everything is at its origin, where they just started. There is no acceleration because nothing's literally moving. It's a straight line on the x-axis. So that is going to happen when you are at rest. When you are going up, or when you start moving, if you have a constant speed and your distance is going up but also your time, you create some kind of slope. And that slope is going to tell you that you're moving away from the origin, which is right over here. If you talk about the velocity is going to be a straight line. But when we say we have a constant slope, or we have a straight line as a slope, that's going to tell us that we have a constant velocity. Let's say 2 meters per second. And that 2 is going to start here and go horizontal this way, because we're not changing the velocity. However, since we're not changing the velocity, we're not changing any kind of speed. Therefore, there's no acceleration. So that's what happens when we increase our speed. Well, we don't increase speed. That's what happens when we move forward. But when we move backwards, we have a negative down slope, a negative line, or a negative straight line. That tells us that our velocity, our constant velocity, is going to be a negative 2. But the thing is, our acceleration is still going to be 0, because we're not actually changing the speed. That concludes the video. I hope this video has helped you understand distance, velocity, and acceleration on a graph. Yes, the only thing that's math related in this video is graphing, but the point of this video was to understand the visuals of what happens to your distance in time, your velocity in time, and your acceleration in time. I hope this video has helped you understand distance, velocity, and acceleration on a graph. Thank you for watching Top Analyze Math Industry. Like and subscribe.